The matrix A can be factored as matrix A equals matrix P times matrix D times the inverse of matrix P, which means matrix A is diagonalizable. We're also given matrix D and matrix P. If vector x is equal to 4 times the vector 3, negative 1 plus 8 times the vector 1, 0, we're asked to find matrix A times vector x without computing matrix A. For the first step, we will complete the diagonalization of matrix A by determining the inverse of matrix P. I'm going to find the inverse of matrix P using the formula for the inverse of a 2 by 2 invertible matrix, shown here. The inverse of matrix P is equal to the matrix 0, negative 1, 1, 3. Now that we have P inverse, we know matrix A is equal to, again, P times D times P inverse. So if we determine this product, we would have matrix A. But again, we're asked to find matrix A times vector x without computing matrix A. To find the product of matrix A times vector x, let's first find the component form of vector x, where the x component is 4 times 3 plus 8 times 1, which is 20, and the y component is 4 times negative 1 plus 8 times 0, which is negative 4. So we can write matrix A times vector x as P times D times P inverse times vector x. Now from here, if we multiplied from left to right, we would find matrix A times vector x, but after multiplying the first three matrices, we would have matrix A, and we're told to find matrix A times vector x without computing matrix A. So we'll treat the right side as if it was a composition of linear transformations and work our way from right to left. So we'll first find the product of P inverse and vector x. The first component is 0 times 20 plus negative 1 times negative 4, which is 4. And the second component is 1 times 20 plus 3 times negative 4, which is positive 8. Working right to left, we will now find the product of matrix D, the diagonal matrix, and the vector 4, 8. The first component is negative 4 times 4 plus 0 times 8, which is negative 16. And the second component is 0 times 4 plus 2 times 8, which is 16. And then finally, we'll multiply matrix P and the vector negative 16, 16. The first component is 3 times negative 16 plus 1 times 16, which is negative 32. And the second component is negative 1 times negative 16 plus 0 times 16, which is 16. So we did find matrix A times vector x without computing matrix A, but I also want to show we would get the same result if we multiply it from left to right. So again, starting with matrix A times vector x as P times D times P inverse times vector x, let's determine matrix P times matrix D, which gives us the matrix negative 12, 2, 4, 0. And let's multiply this result by P inverse, which gives us the matrix 2, 18, 0, negative 4. This matrix here is actually matrix A because this is a result of P times D times P inverse. Multiplying matrix A by vector x, the first component is 2 times 20 plus 18 times negative 4, which is negative 32. And the second component is 0 times 20 plus negative 4 times negative 4, which is 16. So of course we get the same result using either approach. I hope you found this helpful.